Hello everyone and welcome to this channel Lucid Mind Chemistry with Majid. In this video I'll be discussing Chemistry A-Levels Multiple Choice Paper 11 from October-November 2019. You can skip to any question by following timestamps given in the video description. Let's start solving. Question 1. The diagram shows the Boltzmann distribution of energies in a gas. The gas undergoes a reaction with an activation energy EA. The peak of distribution is labeled P. On y-axis we have the proportion of molecules with energy E, while on x-axis we have molecular energy represented by E. EA is the activation energy of the molecules, and this shaded region, it represents those molecules that can be converted into product. If the same reaction is carried out in the presence of a catalyst, which statement is correct? Now we know that catalyst only reduces activation energy by providing alternate pathway. Catalyst has no effect on the average energy of the molecules. So therefore the area under the curve will remain same. Also the shape of the peak will remain same. Only the activation energy will move backward. Now more number of molecules will be converted into product. So activation energy will move backwards. Part A, the peak P is at lower height and the position of EA moves to the left. This is incorrect because peak P does not change. B, the peak P is at lower height. Again, this is incorrect because peak P does not change. Part C, the peak P remains at the same height. This is correct. And the position of activation energy moves to the left. As we have seen that the catalyst reduces activation energy, so it will move to left. So C seems to be correct option. D, the peak P remains at the same height and the position of activation energy moved to the right. This is incorrect because activation energy is decreased, it is not increased by a catalyst. The correct answer is therefore C. Question number 2. Diamond is a pure form of carbon. The mass of diamond can be measured in carats. 1 carat is 0.2 grams of carbon. Which expression gives the number of carats that contain 6 exponential 23 carbon atoms? Now we know that 6 exponential 23 is Avogadro's constant. And it represents 1 mole of a substance. In this case we have carbon, so 1 mole of carbon will be equal to 12 grams as the atomic mass of carbon is 12. Now let's find the number of carats. So number of carats is equal to mass in grams divided by 0.200 grams. As 1 carat is 0.200 grams of carbon, so in 12 grams of carbon we would have 12 divided by 0.200 grams. This expression is the same as the one given in part C. Therefore C is the answer. Question number 3. Which molecule or ion contains the smallest bond angle? A is ethene, as we have 2 carbon atoms and 4 hydrogen atoms. So there is a double bond between 2 carbon atoms. When measuring bond angles, double bond is taken as single bond. So therefore there are 3 bonds around this carbon atoms. So the bond angle will be 120 degrees. Similar is for this carbon atom, the bond angle will be 120 degrees. B is CH3COCH3, which is a ketone. Let's draw the structure. We have 3 carbon atoms and there is double bonded oxygen with the second carbon, 3 hydrogens with the first one and 3 hydrogens with the last one. As we can see that CH4 carbon is making 4 single covalent bonds, so the bond angle in this will be 109.5. Central carbon is making 1 double covalent bond and 2 single bonds, so the bond angle will be 120 degrees. C is NH4 positive, and in NH4 positive we have 3 single covalent bonds and 1 coordinate covalent bond. As the structure is tetrahedral, so the bond angle will be 109.5. Part D is ammonia. In ammonia we have 3 hydrogen-nitrogen bonds and 1 lone pair is also present on nitrogen. As the repulsion between lone pair and bond pair is more, so therefore this bond angle will reduce from 109.5 to 107. So the compound having least bond angle is ammonia. The answer is D. Question 4. 4 compounds are shown: C2H4, C2H5OH, CH3CHO and CH3CO2H. How many of these compounds have an odd number of sigma bonds? Let's draw the bonds. First one is C2H4, which is ethene, so we have double covalent bond between carbon atoms and single bond with 4 hydrogens. Now the number of sigma bonds is 5. We have 5 sigma bonds and 1 pi bond. Second is ethanol. In ethanol we have 2 carbon atoms, 5 hydrogen atoms, one OH group. Now the number of sigma bonds is 8. Third one is CH3CHO. It is an aldehyde. We have 2 carbon atoms and 4 hydrogen atoms. Now the number of sigma bonds is 6. And there is also 1 pi bond. Similarly, in the last one we have carboxylic acid. There are 2 carbon atoms, 4 hydrogen atoms in total, 2 oxygen atoms. So the number of sigma bonds is 7, while we have 1 pi bond. So we can see that we have 2 odd numbers and 2 are even numbers. The answer is therefore B. Question 5. Ethanol CH3CHO, ethanol C2H5OH and methoxymethane CH3O CH3 are 3 organic compounds. Which compound has the highest boiling point and what is the interaction that causes this boiling point to be the highest? Let's draw the structures. First one is CH3CHO. Second is C2H5OH. Third is CH3, oxygen CH3. As we can see that in alcohol, electronegative oxygen is directly bonded with partial positive hydrogen. So therefore hydrogen bonding will take place in this compound. For hydrogen bonding, 2 points must be fulfilled. First one is that the hydrogen is directly bonded with fluorine, oxygen or nitrogen in one of the molecule, and in the second molecule there must be a lone pair available. We can see that in another alcohol molecule Again, oxygen is present and there is a lone pair on oxygen atom. So it is attracted to this hydrogen atom, which causes hydrogen bonding. In other molecules, we just have partial charges, so there are permanent dipole-dipole forces that are present. As hydrogen bonding is stronger as compared to permanent dipole-dipole forces, so the melting point and boiling point will be high. Hydrogen bonding takes place in ethanol. The answer is therefore C. Question 6. What is the oxidation number of sulfur in each species? We have H2S, SO2 and H2SO3. Let's find the oxidation state of sulfur. Now in H2S we have 2 hydrogen atoms, 1 sulfur atom and overall charge is 0. Similarly in SO2 we have 1 sulfur, 2 oxygen and overall charge is 0. In H2SO3 we have 2 hydrogen atoms, 1 sulfur atom, 3 oxygen atoms and again overall charge is 0. The oxidation state of 1 hydrogen is +1, so for 2 hydrogen it will be +2. Then we have sulfur, so sulfur will be equal to -2. So it is -2 in H2S. Similarly for oxygen atom, the oxidation state is -2. So for 2 oxygen it will be -4 and sulfur will become +4. In H2SO3 we have 2 hydrogen atoms, so it will become +2, 1 sulfur atom, 3 oxygen atoms. Sulfur -4 equals 0, so sulfur equals +4. The answer is therefore A. Question number 7. The following data are needed for this question. First is the enthalpy of formation of N2H4 liquid. It is 50.6 kilojoules per mole. Second is enthalpy of formation of N2O4 gas, which is 9.2 kilojoules per mole. Third is enthalpy change of formation of water gas, which equals -241.8 kilojoules per mole. Hydrazine, which is N2H4 liquid, reacts with dinitrogen tetraoxide N2O4 gas to form nitrogen gas and water vapors. The equation is given. What is the enthalpy change for this reaction? So we have to find delta HR for this reaction. As enthalpy change of formation is given, which means that this compound is formed from its elements in their standard states, so we can find out the elements which make up these compounds. So the element is nitrogen, hydrogen and oxygen. These elements will combine together to form this reactant, and then this reactant converts into this product, or these elements can also directly convert into products. So we have 2-step reaction and 1-step reaction. Let's balance this equation. We have 4 nitrogen atoms plus 2 nitrogen atoms. So in total there are 6 nitrogen atoms, so we can write 3. Similarly, we have 3 nitrogen atoms on the product side and 8 hydrogen atoms are present, so we can write 4 with hydrogen and 2 with oxygen. Let's name this step as delta H1 and this one as delta H2. Now we can see that in delta H1, 2 moles of N2H4 liquid are formed. As the enthalpy of formation of N2H4 liquid is 50.6 kilojoules per mole, so for 2 moles it will be 2 into 50.6. Second compound formed is N2O4 gas, and the enthalpy change of formation is 9.2 kilojoules per mole. As only 1 mole is being formed, so we can write 9.2 kilojoules per mole. Now moving towards delta H2, we have 3 moles of nitrogen being formed, and as it is a molecule, so therefore the enthalpy change of formation is 0 for nitrogen. Next, 4 water molecules are being formed, So for 4 number of moles, we will multiply this value with 4. So it is equal to 4 into negative 241.8. According to Hess's law, the energy change in 2 steps is equal to the energy change in single step. So we can write delta H1 plus delta HR, it is equal to delta H2. Now delta H1 consists of enthalpy change of formation of N2H4. So we can write delta H formation of N2H4 liquid multiply by 2 because 2 moles have been formed. Also we have N2O4 being formed, so we can write enthalpy change of formation of N2O4 gas plus delta HR equals enthalpy change of formation of water. Multiply by 4. Now putting values, the values come equal to 101.2 plus 9.2 plus delta HR equals negative 967.2. So delta HR will be equal to negative 967.2 minus 110.4. It becomes 1077.6 kilojoules per mole. The answer is A. Question number 8. Sodium burns in oxygen, giving out heat energy and forming the compound sodium oxide. The equation for this reaction is shown. 2 moles of sodium reacts with half moles of oxygen to form 1 mole of sodium oxide. Which statement about the reaction is correct? A. Enthalpy change for the reaction is equal to twice the bond energy of the sodium-oxygen bond. Now we can see that sodium is a metal and it is from group 1 of the periodic table, while oxygen is a non-metal of group 6. So the bond formed between sodium and oxygen is ionic bond. While here they have shown covalent bond. So therefore A is incorrect. B. Enthalpy change for the reaction is positive. As we can see in the reaction that the heat energy is given out, so it means that it is exothermic reaction. So for exothermic reaction, the enthalpy change is always negative. It is not positive. So B is also incorrect. C. The equation represents the standard enthalpy change of combustion of sodium. Now for combustion of sodium, the standard enthalpy change will be defined as when 1 mole of sodium is burnt in excess oxygen to form sodium oxide. As in this equation, we can see that 2 moles of sodium are used. So therefore C is incorrect. Now part D, the equation represents the standard enthalpy change of formation of sodium oxide. Now this is a true statement because the enthalpy change of formation states that when 1 mole of product, which in this case is sodium oxide, is formed from the reactants in their standard states. So sodium is solid in standard state, oxygen is gas in standard state. So option D is correct. The answer is therefore D. Question number 9. In the chemical equation, W, X, Y and Z are all whole numbers. We have this equation. When the equation is balanced, what are W, X and Y? We can see that this equation is a redox reaction and the medium is acid. Let's balance this redox equation. We will follow these steps. First is to write half equations. For this step, we have to find out the oxidation states. Let's find out the oxidation state of Cl, Mn in the equation. So we have ClO3 negative, MnO4 negative, ClO4 negative, and MnO2 neutral. So we have 1 chlorine atom, 3 oxygen atoms, and overall charge is -1. We have 1 Mn, 4 oxygen atoms, and overall charge is -1. For ClO4, we have 1 chlorine atom, 4 oxygen atoms, and overall charge is -1. Similarly, for MnO2, we have 1 Mn, 2 oxygen atoms, and overall charge is 0. For oxygen atoms, the oxidation state is -2. So for 3 oxygen, it will be -6. So chlorine will become +5. Similarly, in this compound, we have 4 oxygen atoms. So the charge will become -8, or Mn will become +7. In ClO4, we have 4 oxygen atoms. So again, it will become +7. In MnO2, we have 2 oxygen atoms. So Mn will become +4. So the oxidation state is +5, +7, +7, +4. Now we can write the half equations. As we can see that Cl is moving from +5 to +7, so oxidation has taken place, while Mn has moved from +7 to +4, so reduction has taken place. So the oxidation equation will be like this: ClO3 negative, it converts into ClO4 negative. Second half equation is MnO4 negative, it converts to MnO2. Now second point is to balance oxygen. By adding H2O on the opposite side. Now in the first equation, we have 3 oxygen atoms on the reactant side and 4 oxygen atoms on the product side. So we can add water molecule on the reactant side to balance oxygen. Similarly, in reactant, we have 4 oxygen atoms and on product we have 2. So we can add 2 H2O to balance oxygen atoms. Third point is to balance hydrogens. By adding H plus on opposite side. In first equation, we have 2 hydrogen atoms on the reactant side, so we can add 2 H plus to the product. In second equation, we have 4 hydrogen atoms on the product side, so we can add 4 H plus to the reactant side. Next point is to balance charges by adding electrons. Let's find out the charges. On the reactant side, we have -1 charge. On the product side, we have -1 and +2 charges for 2 H plus. So the overall charge is +1. Now in order to balance -1 and +1, we have to add 2 electrons on this side. Now the charges are balanced. For second equation, we have -1 on MnO4, +4 on H plus, so the overall charge is +3. On product side, we have 0 charges, so it is neutral. So in order to make the reactants neutral, we must add 3 electrons. So we can write 3 electrons with the reactants. Fifth point is to equalize electrons by multiplication. As in the first equation 2 electrons are lost, but in the second equation 3 electrons are gained. Now the number of electrons lost must be equal to the number of electrons gained, so we can multiply the first equation by 3 in order to make it 6 electrons, and we can also multiply the second equation by 2 in order to make it 6 electrons. Now the first equation will become like this. We have 3H2O, 3ClO3, negative, 3ClO4, negative, 6H plus, and 6 electrons. The second equation will become 6 electrons, 2MnO4, negative, 8H positive, 2MnO2, 4 water molecules. The last step is to add both equations. Now we can see that number of electrons lost is equal to number of electrons gained, so we can cancel them out. Similarly, we have 6H positive formed and 8H positive gained, so it will cancel to become 2H positive. Now we can write both equations. 3H2O, 3ClO3 negative, 2MnO4 negative, 2H positive. It forms 3ClO4 negative, 2MnO2, and 4H2O. ClO3 is given as W, so W is equal to 3. MnO2 negative is given as X, so X is equal to 2. H plus is given as Y, so Y is also equal to 2. The answer is therefore D. Question 10. Two compounds X and Y react to produce compound Z. The reaction is reversible. An equilibrium is established. When X and Y are mixed together in a closed system, a dynamic equilibrium is gradually established. Which graph could represent the change in the rates of forward and reverse reactions over time? Dynamic equilibrium means that the equilibrium state is not static. Continuously reactants are converted into products and continuously product is converted back into reactants. So in dynamic equilibrium state, the rate of forward reaction is equal to the rate of reverse reaction. In the key, they have given that this dotted line represents the rate of forward reaction, while this dashed line represents the rate of reverse reaction. Now in the start, the amount of reactant was maximum while the amount of product was 0. So therefore the rate of forward reaction was maximum while the rate of reverse reaction was 0. Now we can see that at equilibrium, the rate of forward reaction is still greater than the rate of reverse reaction. In B, we can see that the rate of forward reaction has decreased continuously to become 0. This is not possible because in equilibrium, the rate of forward is equal to the rate of reverse reaction. So B is also incorrect. In C, we can see that after a while, the rate of forward reaction is exactly equal to the rate of reverse reaction as both lines are on the same height. So C could be the correct option. In D, we can see that the rate of forward reaction has become 0. And the rate of reverse reaction has become maximum. This is also incorrect. The answer is therefore C. Question number 11. The reaction between sulfur dioxide and oxygen is reversible. The Kc for this reaction is given as 280 per mole decimeter cube as 1000 Kelvin. In an equilibrium mixture at 1000 Kelvin, the sulfur dioxide concentration is 0.2 mole per decimeter cube and the oxygen concentration is 0.1 mole per decimeter cube. What is the sulfur dioxide concentration? Now we can use the formula equilibrium concentration Kc is equal to the concentration of product, which is SO3 raised to the power is number of moles. So there are 2 moles divided by the concentration of reactants. So first reactant is SO2 and its number of moles is 2. Second reactant is oxygen and its number of moles is 1. By rearranging, we can find the concentration of SO3. So it will be Kc into SO2 square into O2. Now by putting values, the value of Kc is given as 280. SO2 is also given as 0.2. Oxygen is given as 0.1. So it becomes 1.12. Now we can take under root on both sides and the concentration of SO3 will become 1.058 mole per decimeter cube. The answer is therefore A. Question 12. Which oxide will cause an increase in pH when added to water? A is MgO. MgO is metal oxide and it is basic in nature. So it will increase the pH of water when it is dissolved in water because it will form magnesium hydroxide. B is aluminum oxide. C is silicon dioxide. Both are insoluble in water, so no change in pH will occur. D is SO2, which is acidic oxide, as it is a non-metal oxide and it will dissolve in water to form acid, so it will decrease the pH. The answer is therefore A. Question 13. X, Y and Z are consecutive elements in period 3 of the periodic table. Element Y has the highest first ionization energy and the lowest melting point of these 3 elements. What are the identities of X, Y and Z? Now the elements given in this table based on the atomic numbers can be written in a sequence like this. We have sodium, magnesium, aluminum, silicon, phosphorus and sulfur. Let's first look at the melting point. We know that sodium, magnesium and aluminum are metals and the melting point increases as the number of electrons lost increase. The metallic bonding becomes stronger, so therefore melting point increases. Now in silicon we can see that silicon forms giant covalent compound. Because of the giant structure, the melting point will be more than aluminum. Now phosphorus occurs in the form of small molecules made up of 4 atoms and sulfur in the form of atoms of 8. So the melting point will drastically decrease in phosphorus and increase a little bit in sulfur. This is because phosphorus has less intermolecular forces of attraction as compared to sulfur. Now in general, ionization energy increases across the period. This is because the atomic number increases and also the electrostatic forces increase. The atomic number of silicon is 14, so we can write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p, x, 3py, and each has one electron. Similarly, for phosphorus 15, we can write the electronic configuration 1s2, 2s2, 2p6, 3s2, and then we have 3 single electrons in each p orbital. Similarly, for sulfur, we can write electronic configuration as 1s2, 2s2, 2p6, 3s2, and then in 3p orbitals we have 4 electrons, in which 2 electrons are present in px, 1 in py, and 1 in pz. Now the ionization energy will increase from silicon to phosphorus as the atomic number has increased, but from phosphorus to sulfur the ionization energy will decrease. This is because this electron is removed first and there is spin pair repulsion present. Due to this repulsion between these electrons, the energy required to remove electron will be less. So P has the highest first ionization energy among these three, and also P has the lowest melting point, so Y should be phosphorus. The answer is therefore D. Question 14. A 5 gram sample of an anhydrous group 2 metal nitrate loses 3.29 grams in mass when heated strongly. Which metal is present? Let's start by writing a general equation of metal nitrate from group 2. It decomposes into metal oxide, which is solid, along with nitrogen dioxide, which is gas, and oxygen, which is also gas. Let's balance this equation. We have metal M on both sides, which is equal. Now the number of nitrogen atom is 2 on the reactant side, so we can write 2 with the product. There are 6 oxygen atoms on the reactant side, so therefore we can write 1 by 2 with oxygen to make it 1. So the total oxygen atoms on the product will be 6. In the question they have given 5 grams sample mass, so therefore the mass of metal nitrate is 5.00 grams. And it says that after heating strongly it loses 3.29 grams, which means that the mass of these gases was collectively 3.29 grams, which is lost. So therefore the mass of metal oxide that is left will be 5 minus 3.29, which is equal to 1.71 grams. As we can see that the number of moles of both metal nitrate and metal oxide is equal in the balanced equation. Both have 1 mole each. Therefore we can write number of moles is equal. Now using the formula of moles, moles is equal to mass in grams divided by molecular mass. Let's find the molecular mass. We have nitrate, nitrogen is 14, 1 oxygen is 16, so 3 will be 48. As there are 2 nitrates, so it will be multiplied by 2. So it becomes 124. The atomic mass of M is still unknown, so we can write M plus 124. Similarly, on this side, the number of moles is equal to mass in grams divided by molecular mass. We just have 1 oxygen atom, so the molecular mass is M plus 16. The mass in grams is given, which is 5 gram for this compound and 1.71 grams for this one. So we can write 5 divided by M plus 124 is equal to 1.71 divided by M plus 16. By cross multiplying, we can find the molecular mass of M. So now it will become 5 into M plus 16 equals 1.71 into M plus 124. Now it will become 5M plus 16 into 5, which is 80, and 1.71M into 1.71 into 124, which becomes 212.04. Now 5m minus 1.71m equals 212.04 minus 80. So it becomes 3.29m equals 132.04. Dividing both sides with 3.29, this will cancel out, so m equals to 40.133. From periodic table we know that the atomic masses of magnesium is 24.3, for calcium it is 40.1, for strontium it is 87.6, while for barium it is 137.3. So our value is equal to the one with calcium. The answer is therefore B. Question 15. Solutions P and Q each contain a different group 2 ion at the same concentration. One contains magnesium plus 2 and the other contains barium plus 2. Tests are carried out on separate 5 cm³ samples of P and Q. In test 1, they have added 1 cm³ of 0.1 mole per decimeter³ sodium sulfate, while in test 2 they have added the same amount of sodium hydroxide. What are the results of these tests? As we have magnesium plus 2 ion present, so it will make magnesium sulfate in the first test, while in the second test magnesium plus 2 upon addition will form magnesium hydroxide. Similarly, barium plus 2 will form barium sulfate in the first test, and in the second test it will form barium hydroxide. As in the results, we have to find out the precipitation, so therefore let's find out which is more soluble among sulfates and among hydroxides. Now we know that group 2 sulfates become less soluble moving down in the group, so therefore magnesium sulfate is more soluble and barium sulfate is less soluble. So therefore more precipitate will be formed with barium plus 2 in test 1. So option A and B could be correct. Now comparing the solubility of hydroxides, we know that in group 2 the hydroxides become more soluble moving down in the group, so therefore magnesium hydroxide is less soluble and barium hydroxide is more soluble, so therefore more precipitate will be formed with magnesium plus 2. The answer is therefore B. Question 16. Chlorine and bromine have different volatilities. Which row identifies the more volatile of the two elements and gives the correct explanation? In group 7 elements, chlorine is above bromine, and we know that going down in the group the intermolecular forces increase. This is because intermolecular forces depend on the number of electrons and also on the size of atom. So the size of atoms increases as the successive number of shells increases. So bromine has more intermolecular forces as compared to chlorine, so therefore the volatility will decrease. So among chlorine and bromine, chlorine will be more volatile as the intermolecular forces are weaker in chlorine. The explanation is that instantaneous dipole-induced dipole forces are greater in bromine than they are in chlorine. This is a true statement because the size of bromine is larger, so therefore the intermolecular forces such as instantaneous dipole and induced dipole forces will be greater. And the second is incorrect because it will be less in chlorine as compared to bromine. The answer is therefore C. Question number 17. Sodium azide NaN3 is dissolved in water. Acidified silver nitrate is added to the solution and a white precipitate forms. Aqueous ammonia is then added to the white precipitate. The azide ion N3 negative has similar chemical properties to the chloride ion. Which row of the table can be predicted from this information? First is the formula of white precipitate. As we know that the charge on silver is +1 and on N3 negative it is given as -1. So when compound is formed, equal charges cancel out. So it will become AgN3. So AgN3 is correct. As the chemical properties of N3 negative is similar to Cl negative, so we can say that when silver nitrate is added to sodium chloride, or it can be sodium azide, the product formed will be silver chloride. In case of NaCl, so it will be silver azide in case of NaN3. Now for silver chloride precipitate, we know that it is soluble in aqueous ammonia. So same will be true for silver azide. So colorless solution will be formed. The precipitate does not remain, so it is incorrect. This one is correct. The answer is therefore A. Question 18. Which type of reaction occurs when solid ammonium sulfate is heated with an excess of sodium hydroxide solution? Now you should always remember that whenever ammonium sulfate salt is reacted with alkali, it forms salt, which is sodium sulfate, water, and ammonia gas is released. This is also a test for the presence of ammonium ion. Now we can see that from reactants we have NH4 positive, and from sodium hydroxide we have OH negative, which are reacting together in this equation to form NH3 along with H2O. Now ammonium sulfate was solid, sodium hydroxide is aqueous, sodium sulfate is a soluble salt, water is liquid, and ammonia is in the form of gas. Let's look at the type of chemical reaction. A is acid-base reaction. As we can see that ammonium ion is donating H plus to this OH negative to make H2O and ammonia gas. So therefore NH4 positive is proton donor, and therefore it is Bronsted-Lowry acid. Similarly OH negative is proton acceptor, so it is Bronsted-Lowry base. As both are being neutralized in the form of water, so therefore it is acid-base reaction. B is precipitation. As we can see that no precipitate is formed in the product, so B is incorrect. C is redox. No change in oxidation state has taken place. In ammonia, the oxidation state of nitrogen is -3. In ammonium, the oxidation state of nitrogen is still -3. So it is not redox. D is thermal decomposition. Although we have heated this chemical reaction, but in this reaction two different compounds have reacted to form different products, so therefore it is not thermal decomposition. In thermal decomposition, one compound is broken down into different compounds. For example, calcium carbonate is thermally decomposed into calcium oxide and carbon dioxide. The only correct option is therefore A. Question 19. Catalytic converters are fitted in the exhaust systems of many cars. Which gas causes acid rain if it is released into the air and is removed from car exhaust fumes by a catalytic converter? First one is carbon dioxide. Now carbon dioxide does cause acid rain because it dissolves in water to form carbonic acid, which reduces the pH of water. But second point is incorrect for carbon dioxide because carbon dioxide is the main combustion product, so it is not removed by catalytic converter. So A is incorrect. Second is carbon monoxide. Now carbon monoxide does not dissolve in water as it is a neutral oxide, so it does not cause acid rain. So B is also incorrect. C is hydrocarbon vapor. Now hydrocarbon vapor is insoluble in water as it is non-polar organic compound, so it will not cause acid rain. So C is also incorrect. D is nitrogen dioxide. Now nitrogen dioxide is acidic gas as it dissolves in water to form HNO2, which then can be further oxidized to HNO3. Now NO2 gas can be reduced in catalytic converter to convert back into nitrogen gas and oxygen gas. So both statements are true for nitrogen dioxide. Therefore D is the answer. Question 20. Which substance reacts with trichloroethene to give a chiral product? Chiral product is that product in which carbon is attached to 4 different elements or groups. Trichloroethene is the one having 2 carbon atoms with double bond, and we have 3 chlorine atoms. First one is the addition of Br2. So Br2 can be added in this compound on double bonds. The double bonds will be converted into single covalent bonds and the product will be like this. 1 bromine atom on first carbon atom and 1 bromine will be on second carbon atom. Now we can see that this carbon is bonded to 4 different elements or groups. So therefore the product is chiral in nature. So A could be correct. Second is the reaction with HCl. Now HCl can be added in 2 different ways. Either hydrogen atom will be attached with steric carbon and chlorine with the other carbon, or chlorine is attached with the steric carbon and hydrogen is with the other carbon atom. The first product is the one in which this compound is formed. Double bond has converted into single bond. Hydrogen atom attaches with the first carbon and chlorine with the second carbon. As we can see that similar atoms are present on each carbon atom. So therefore this is not chiral compound. The second product formed could be like this. Now chlorine is attached with the first carbon while hydrogen is attached with the second carbon. Again we can see that similar atoms are present on each carbon, so therefore the product is not chiral. So B is incorrect. Third is the reaction with sodium cyanide. As we know that cyanide is a nucleophile, so it can replace chlorine atom. The double bond is not disturbed. So when double bond is present, the carbon is not chiral. So NaCN is also incorrect. Similarly with sodium hydroxide, nucleophilic substitution will occur as OH is a nucleophile. So chlorine can be replaced by OH. Again double bond is not disturbed, so therefore the product is not chiral. The correct answer is therefore A. Question 21. Alkanes are saturated hydrocarbons, which means that they have single bonds present. Which type of reactions are alkanes most likely to undergo? First is electrophilic addition. Now, electrophilic addition occurs in alkenes because there is double bond present and double bond is converted into single bond and some product is added. So A is incorrect. B is electrophilic substitution. Now, for electrophilic substitution, an electrophile must be present, and electrophile is always added to double bonds or pi electrons. For example, the addition of NO2 positive in benzene is electrophilic substitution reaction. In alkanes, electrophilic substitution does not take place because there are no pi electrons present, so B is incorrect. C is free radical substitution. Now, alkanes can be converted into products upon reaction with free radicals such as bromine radical. So the product formed can be like this. Now this reaction will continue until all of the hydrogen atoms are replaced by bromine. So C is correct. D is nucleophilic addition. Now we know that addition cannot take place in alkanes because no pi bonds are present. Nucleophilic addition can take place in aldehydes and ketones. For example, the addition of HCN to form hydroxynitrile. So D is incorrect for alkanes. The correct answer is therefore C. Question 22. An alkene reacts with hot concentrated acidified potassium manganate 7 to produce a single organic product as shown. This is the product that is formed. What is the structure of the alkene? Now we know that hot concentrated acidified KMnO4 can break the double bond in alkene to give the product. The product depends on the type of carbon atoms involved in the double bond. For example, if the carbon atom present in the double bond is attached with two hydrogen atoms, so it will convert into carbon dioxide upon oxidation. If the double bonded carbon is attached with one alkyl group and one hydrogen atom, it is first converted into aldehyde and then further oxidized into carboxylic acid. In third case, if the double bonded carbon is present with two alkyl groups directly attached, so it will be converted into ketone functional group. Let's find out what products are formed. This carbon atom is attached with two alkyl groups, so it is converted into ketone. This carbon atom is attached with one alkyl group and one hydrogen atom, so it will be converted into carboxylic acid. The product formed will be like this. Where this CH3 is this one and this COOH is this carbon. Now in the product we have 7 carbon atoms in the long chain and methyl group is attached with the 4th carbon. While in the compound shown we have 6 carbon atoms in the long chain and methyl group is attached with the 3rd carbon. So A is incorrect. For compound B, we can see that this carbon atom is attached to one alkyl group and one hydrogen atom, so it is converted into carboxylic acid, and this carbon atom is attached to two alkyl group, so therefore this is converted into ketone. The product formed will be like this. This is the first carbon atom which is converted into carboxylic acid, and this is the second one that has converted into ketone. Again, we can see that in the long chain we have 7 carbon atoms, whether in the product it shows 6 carbon atoms. So B is also incorrect. Now for compound C, we can see that this carbon is attached with 1 hydrogen atom and 1 alkyl group, so it will be converted into carboxylic acid, while this one is attached to 2 alkyl groups, so it is converted into ketone. The product's form will be like this. The first carbon atom is converted into COOH, then we have methyl group attached, then CH2, CH2 and ketone. Now this carbon atom is this one, and this is this one. Now we can see that in the long chain there are 6 carbon atoms present, and on second carbon we have ketone, while on third carbon atom no methyl group is attached, while in the given product on third carbon atom there must be a CH3 group present. So C is incorrect. Now in part D, this carbon atom is attached with 1 hydrogen and 1 alkyl group, so it is converted into carboxylic acid, and this one is attached to 2 alkyl groups, so it is converted into ketone. Let's draw the structures. With this carbon we have methyl group attached, then we have ketone functional group. Now this carbon is this one, and this ketone is given by this carbon atom. In the long chain we have 6 carbon atoms, and on second carbon we have ketone functional group, which is correct. On third carbon we have methyl, which is correct, and on 6th carbon atom we have carboxylic acid functional group, which is also correct. The answer is therefore D. Question 23. A tertiary bromoalkane indicated here by CBr reacts with aqueous sodium hydroxide. The mechanism has the reaction pathway shown. Now we can see there are 2 components. One is X having high energy, second is Y having low energy. On y-axis we have energy given, and on x-axis we have progress of the reaction. These are the reactants and this is the product that is formed. Which point in the diagram is correctly identified? In the question, tertiary bromoalkane is given, which is CBr. So what happens with the tertiary bromoalkane substitution? There are 3 alkyl groups attached with these carbon atoms directly. Bromine is electronegative, so it has partial negative charge, while the charge on carbon is partial positive. Now what happens in substitution? That in the first step this bond will be broken and tertiary carbocation is formed. Now this tertiary carbocation is stable because there are 3 alkyl groups directly attached, and because of the positive inductive effect it stabilizes the carbocation. Now this carbocation is a stable product. Now the stable product must have low energy. In the diagram we have X is at high energy and Y is at low energy. So therefore this product should be Y. In option A, X is given as C positive carbocation intermediate. This is incorrect because X is at high energy. In B, X is given as this intermediate. Now this is incorrect because this transition state is formed from primary halogenoalkanes. while the one given in the question is tertiary halogenoalkane. In C, it is given that Y is carbocation. Now as Y is at low energy, so this should be correct option. In D, Y is given as this transition state. Again, this is incorrect because this is for primary halogenoalkane. Correct answer is therefore C. Question 24. Bromoethane and chloroethane are added separately to water. Hydrolysis reaction occurs. Which compound hydrolyzes more rapidly and what is the mechanism? Now two options are given. One is bromoethane and second is chloroethane. In bromoethane, carbon is bonded with bromine, while in chloroethane, carbon is bonded with chlorine. Now we know that from data booklet, the carbon-chlorine bond strength is quite high. It is 346 kilojoules per mole, while bond breaking energy for carbon-bromine is 290 kilojoules per mole. So low energy means faster reaction. We can say that bromoethane gives more rapid chemical reaction. Now let's look into the mechanism, whether it is electrophilic substitution or nucleophilic substitution. In hydrolysis reaction, OH negative from water acts as a nucleophile. Now what will happen that due to more electronegative bromine atom, it will become partial negative and carbon will become partial positive. Now OH negative will attack this partial positive carbon and this bond will be broken. The new product formed is OH and Br is removed in the form of negative ion. As nucleophile is involved, so therefore this is nucleophilic substitution reaction. The answer is therefore B. Question 25. Alcohol X is oxidized to form compound Y. The composition of Y is 54.54% carbon, 36.36% oxygen and 9.10% hydrogen. The molecular mass of Y is 88. What could be the structure of alcohol X? Let's look into option A. We have 4 carbon atoms in the long chain and OH is attached to this carbon atom, which makes it secondary alcohol. Now secondary alcohol is oxidized into ketone. The product form will be like this. There are 4 carbon atoms in the product, 8 hydrogen atoms and 1 oxygen atoms. Let's find out the molecular mass. It is 48 for 4 carbon atoms, 8 for 8 hydrogen and 16 for 1 oxygen. So the molecular mass becomes 72. It should be 88, so therefore A is incorrect. Also we can find the number of carbon atoms from the given percentage. As there is 54.54% carbon in 88 molecular mass, so we can find the molecular mass of carbon. So 54.54 divided by 100 into the molecular mass, which is given as 88. The molecular mass of carbon becomes equal to 48. Now we know that for 1 carbon the molecular mass is 12, so therefore 48 will be equal to 4 carbon atoms. So 4 carbon atoms must be present in the product. In A we had 4 carbon atoms, but A is wrong. In B we have 5 carbon atoms. Now 5 carbon atoms is incorrect. In C again we have 4 carbon atoms. This could be true. In D we have 5 carbon atoms, so D is also incorrect. Let's do the reaction for C. We have 4 carbon atoms. And as OH is attached with the last carbon, so it is primary alcohol and it will be oxidized into aldehyde. And then it will be further oxidized to carboxylic acid. The molecular formula of this aldehyde is C4H8O, which is similar to this one. So the molecular mass is again 72. So it is not this product that is formed. In second product, we have 4 carbon atoms, 8 hydrogen atoms and 2 oxygen atoms. So the molecular mass comes equal to 88. It means that alcohol X was this compound, which is C. So therefore C is the answer. Question 26. The diagram shows the structure of compound Z. This is compound Z. We have alkene, ketone and aldehyde functional group present. What is the product of the reaction between compound Z and an excess of NaBH4? Now we know that NaBH4 is reducing agent. It has no effect on alkenes, while it can reduce aldehydes back into primary alcohol, and it can also reduce ketone back to secondary alcohols. So this will be converted into secondary alcohol group, and this one will be converted into primary alcohol. And alkene will be unaffected. So in A, the alkene is unaffected. This one is secondary alcohol and this is primary alcohol. So A is correct. In B, the alkene has changed. So B is incorrect. Again in C, the alkene has converted it to alkane, which is not possible. In D, alkene is intact while the ketone has not changed. So therefore D is incorrect. The correct answer is therefore A. Question 27. Compound Q shows the following reactions. Number 1 is that it gives an orange precipitate with 2,4-dinitrophenylhydrazine. Now this test shows the presence of aldehyde and ketone functional group. Because both aldehyde and ketone give positive result with 2,4-D and pH. So it is not alcohol, it could be aldehyde or ketone. Second is that it gives a red-brown precipitate with Phelan's reagent. Now Phelan's reagent gives positive result with aldehyde and negative with ketone. So therefore it is aldehyde and not ketone. Third reaction is that it gives a pale yellow precipitate with alkaline aqueous iodine. Now among the aldehydes left, there must be a methyl group directly attached with carbonyl carbon. Let's draw the structure of ethanol and propanol. In ethanol we have 2 carbon atoms in total, and this group is present. In propanol there are 3 carbon atoms in total, and we have ethyl functional group which does not give positive result with alkaline aqueous iodine. So A could be the correct option. The answer is A. Question 28. Tartaric acid. We have carboxylic acid group, secondary alcohol groups attached. Again carboxylic acid groups is found in many plants. A sample of tartaric acid reacts with an excess of lithium aluminum hydride to form organic product J. What happens when sodium hydroxide aqueous is added to separate samples of tartaric acid and J? Now you should know that lithium aluminum hydride is a powerful reducing agent, so it will be able to reduce carboxylic acid back into primary alcohols. while primary alcohol is not affected by lithium aluminum hydride. As in the question, we have two carboxylic acid functional groups present, so the product formed will be like this. This will be converted into alcohol. We already had an alcohol with the second carbon and the third carbon. The fourth carbon carboxylic acid will also be converted into alcohol. Now this product is J. Now when J is reacted with sodium hydroxide aqueous, it does not give any product because alcohols do not react with aqueous sodium hydroxide. Let's see the second reaction of tartaric acid with sodium hydroxide aqueous. We have 4 carbon atoms in tartaric acid. 2 alcohol groups are present. 2 carboxylic acid groups are present. Upon reaction with sodium hydroxide aqueous, carboxylic acid will be neutralized to salts. So it will form sodium salt of carboxylic acid on one end and again sodium salt of carboxylic acid on the other end, and 2 water molecules will be formed. So we can see that tartaric acid can react with aqueous sodium hydroxide while J cannot react with sodium hydroxide aqueous. So A is incorrect, B is correct. The answer is therefore B. Question 29. When this compound is warmed with a little concentrated sulfuric acid, a cyclic compound is formed. What is the skeletal formula of the cyclic compound? Now we know that concentrated sulfuric acid is a dehydrating agent, so it will remove water from this compound. Let's see how cyclic compound is formed. On first carbon atom we have OH functional group. Between second and third we have alkene, and on last we have functional group present. Now what can happen is that this OH and this hydrogen can be removed in the form of water, and this carbon attaches itself to this carbon atom to form a cyclic compound. So we can draw cyclic structure like this. We have CH2, then CH double bonded with another CH, then we have carboxylic acid carbon, then oxygen, and then this carbon is attached with oxygen atom. Now starting from carboxylic acid carbon, this is first, second and third, so we can see that the double bond is present between second and third carbon. In the first one there is no carboxylic acid, ketone is present, so A is incorrect. In B we have this one as carboxylic acid, so if this is the first carbon atom then double bond should be present between second and third, so B is also incorrect. In C we have this one as carboxylic acid carbon, so if it is 1 then the double bond is present between second and third. This is correct. And in total we have 4 carbon atoms, so C could be the correct option. In D we have 1 carboxylic acid and 1 ketone, which is not possible. The answer is therefore C. Question 30. The infrared spectrum of a compound P is shown. This compound we can see that there is no peak between 1600 and 1700 per centimeter, so it means that carbonyl carbon is absent. So aldehyde, ketones, ester is not possible. We can see that this peak is present at 2950 per centimeter, so it could be of carbon and hydrogen. And this broad peak is present between 3200 and 3600, so it could be because of the presence of alcohol functional group. Let's look into the options. A is methyl ethanoate, which is ester. The structure will be like this. As carbonyl peak is absent, so this is incorrect. B is aldehyde propanol. Again we have carbonyl carbon present, so B is incorrect. C is propanoic acid, in which we have 3 carbon atoms. Again we have carbonyl carbon peak, so C is incorrect. D is propane 2-ol. So we have alcohol group whose peak is present between 3200 and 3600, and we also have carbon hydrogen whose peak is present at 2950. The answer is therefore D. Question 31. A particular atom of germanium has a nucleon number of 70. Which statements about germanium atom are correct? In first option, we have to find the number of electrons. In second, we have to find the neutrons. And in third, we have to find the number of protons. Germanium is given as 70 and 32. Now the number of protons is 32. As there is no charge, so the number of electrons is also 32. And number of neutrons is equal to 70 minus 32, which becomes 38. 1. It has the same number of electrons as a selenium plus 2 7934 ion. Now in selenium the atomic number is 34, which means there were 34 electrons present. Now when the charge is plus 2, it means 2 electrons are lost. Now the number of electrons left is 32 electrons. Now this is in accordance with germanium, so option 1 is correct. 2. It has the same number of neutrons as an atom of zinc 6830. Let's find the number of neutrons in zinc. 68 minus 30, it equals 38 neutrons. This is also similar to the one present in germanium. 3. It has half as many protons as an atom of GD 64160. Now the number of protons in GD is 64, while the half of that will be 32, and 32 protons are present in germanium. As all 3 options are correct, the answer is A. Question 32. The first ionization energy of chlorine is greater than that of sulfur. Which factors contribute to this? Number 1. Chlorine has more protons in its nucleus than sulfur does. Now the atomic number of chlorine is 17, while that of sulfur is 16. Now we know that when the number of protons increase, the nuclear charge increases and the force of attraction between the nucleus and the outer electron also increase. So therefore, due to greater number of protons in chlorine, its ionization energy will be higher. So option 1 is correct. 2. Chlorine has greater electron shielding than sulfur does, as both chlorine and sulfur are present in the same period. So there are 2 inner shells present in an atom of chlorine, and again there are 2 shells present in an atom of sulfur that shield the outer electrons. So chlorine does not have greater shielding effect as compared to sulfur, so therefore 2 is incorrect. 3. The covalent bonds in chlorine molecules are stronger than those in sulfur molecules. This does not have anything to do with ionization energy because covalent bonds are being broken, while in ionization energy, the electron is removed from isolated gaseous atom. So there is no involvement of covalent bonds. As only option 1 is correct, the answer is therefore D. Question 33. Liquids X and Y do not react with one another. They have identical boiling points. When a particular volume of X is shaken with a similar volume of Y, they form a liquid mixture Z. The average intermolecular forces in liquid Z are stronger than the average of the forces in X and the forces in Y. Which deductions from this information are correct? Number 1. The mixing of X and Y is exothermic. As we know that formation of intermolecular forces releases energy. So therefore formation of intermolecular forces is exothermic. For example, freezing is the process in which intermolecular forces are formed, and freezing is exothermic in nature. As in the question, we can see that the average intermolecular forces in the mixture Z is stronger. It means that the intermolecular forces have developed, so therefore it will be exothermic. So option 1 is correct. Number 2, the vapor pressure of liquid Z will be less than that of either liquid X or liquid Y at the same temperature. Now, vapor pressure is inversely proportional to intermolecular forces of attraction. Because stronger the forces of attraction between the liquid molecules, it will be more difficult for them to get separated into vapors. As we can see that the intermolecular forces are now stronger in mixture Z, so therefore the vapor pressure will be reduced. So option 2 is also correct. 3. The boiling point of liquid Z will be lower than that of either liquid X or liquid Y at the same pressure. Now we can see that as intermolecular forces are stronger in mixture, so the boiling point will also become higher. It will not be lower, so therefore option 3 is wrong. As option 1 and 2 are correct, the answer is therefore B. Question 34. The stoichiometry of a catalyzed reaction is shown by the equation below. This is the equation. P and Q react to form R and S. 2 experiments are carried out in which the amount of R is measured. The results are shown in the diagram. We can see that in experiment 1 the amount of R is greater. In experiment 2 the amount of R is less. Also experiment 1 is more steep as compared to experiment 2. Which changes in conditions could explain the results shown? 1. A lower pressure was used in experiment 2. Let's look into the number of moles of reactants and products. So in reactant we have 1 mole of P and 1 mole of Q. So in total there are 2 moles of reactant that are present as gases. And in product we just have 1 mole of R, while S is in liquid form, so there is no effect of pressure on S. So only 1 mole will be considered in the product. Now we know that when pressure is increased, the equilibrium moves from more number of moles to less number of moles. While in option 1 a lower pressure was used, it means that the equilibrium will move in the backward direction and the amount of R formed will be less. As in experiment 2, we can see that the amount of R is less as compared to experiment 1. So first statement is correct. Option 2, a different catalyst was used in experiment 2. Now catalyst increases the rate of reaction by providing alternate pathway. It is not necessary that when different catalyst is used, the rate of reaction will remain same. So there could be different catalysts present in experiment 1 and experiment 2. So option 2 could be correct. 3. Product S was continuously removed from the reaction vessel in experiment 2. As product S is continuously removed from reaction vessel, so then what will happen that upon removal of product, the reaction should move in the forward direction and more amount of R should be produced. While in experiment 2, the less amount of R is present, so therefore option 3 is incorrect. As option 1 and 2 are correct, so therefore answer is B. Question 35. Which statements are correct? Number 1. Chloride ions are oxidized when concentrated sulfuric acid is added to sodium chloride. Now we can see that when concentrated acid is added to NaCl, the product formed are sodium hydrogen sulfate along with HCl, and this HCl is not further oxidized by sulfuric acid. Now the oxidation state of chlorine in reactant is -1, while in HCl again it is -1, so therefore no change in oxidation state has taken place, so 1 is incorrect. 2. A disproportionation reaction takes place when chlorine is added to cold sodium hydroxide. Now disproportionation means self-oxidation reduction. Let's write the chemical equation. When chlorine is added to cold sodium hydroxide, what happens that sodium chloride, sodium chlorate and water is produced. The oxidation state of chlorine in reactant is 0 as it is in molecular form. In sodium chloride it is -1. In sodium chlorate it is +1. So reduction and oxidation has taken place. So therefore this is called disproportionation reaction. 3. An acidic solution forms when chlorine is added to water. When chlorine is added to water, what happens is that it forms HCl aqueous along with HClO. As HCl is acid, so therefore as options 2 and 3 is correct, so therefore answer is C. Question 36. Nitrogen gas is unreactive whereas oxygen gas and chlorine gas are reactive. Which statements help to explain this difference? Number 1. The two nitrogen atoms in a nitrogen molecule are held together by very strong triple bond. This is true because nitrogen makes triple covalent bond with another nitrogen atom, and a lot of energy is required to break this bond. It is about 994 kilojoules per mole. So option 1 is correct. 2. The triple bond between two nitrogen atoms is not polar. The bonds in oxygen and chlorine are polar. This is incorrect statement because neither of the bonds in nitrogen and oxygen and chlorine is polar, as they are atoms of same element. So nitrogen, oxygen and chlorine, all three are non-polar. So option 2 is incorrect. Option 3. The atoms in nitrogen have a full outer shell of electrons. The atoms in oxygen and chlorine do not have a full outer shell of electrons. This is also incorrect statement because the octet in all nitrogen, oxygen and chlorine is complete. Nitrogen makes triple bond with another nitrogen atom and 8 electrons are complete in the outer shell, while in oxygen double bond is formed between two oxygen atoms and 2 lone pairs are also present on each oxygen atom. Similarly, in chlorine, single covalent bond is formed between 2 chlorine atoms and 3 lone pairs are also present on each chlorine atom. As only option 1 is correct, the answer is therefore D. Question 37. The structure of tiglic acid is given. We have alkene functional group. Also carboxylic acid functional group is present. Which statements about the properties of one molecule of this acid are correct? Number 1. It contains 2 pi bonds. Let's draw the structure of this compound. We have CH3, then CH double bond carbon with methyl group attached, and also carboxylic acid is present. So as we can see that we have 2 pi bonds present. So option 1 is correct. Option 2, it contains 4 lone pair of electrons. Let's find out the number of lone pairs. As we can see that each carbon atom is making 4 bonds, so no lone pair is present on carbon atoms, while oxygen is making double covalent bonds, so 2 lone pairs are present on this oxygen atom, while 2 lone pairs are present on this oxygen atom. So in total there are 4 lone pairs of electrons that are not involved in bonding, so option 2 is correct. Option 3, it has all its atoms in the same plane. This is incorrect because carbon is making 4 single covalent bonds and the structure is tetrahedral. And in tetrahedral the atoms are not in the same plane. Option 1 and 2 are correct. The answer is therefore B. Question 38. Which compounds on heating with an excess of concentrated sulfuric acid produces only one product with the molecular formula C7H10? Now we know that concentrated sulfuric acid is a dehydrating agent and it will remove water in an elimination reaction of alcohols. Now water is removed in such a way that OH present with one carbon atom is removed and hydrogen from adjacent carbon atoms is also removed. Similarly, OH from this carbon atom will be removed while hydrogen from this adjacent carbon atom is removed. The products formed will be like this. If hydrogen is removed from this carbon, then double bond will come between these 2 carbon atoms and another double bond will come between these 2 carbon atoms. While in second product, if hydrogen atom is removed from this carbon atom, so the double bond will come between these 2 carbon atoms and one is present between these 2 carbon atoms. Now let's find out the position of double bond. This is first carbon, second, third, fourth and fifth. So the double bond is present between first, second and fourth, fifth carbon. In second structure, again the double bond is present between first and second carbon and fourth and fifth carbon atoms. In total we have 7 carbon atoms in both the structures. So the formula is C7H10. So we can say that only one product is formed as the structure is similar, so therefore option 1 is correct. In option 2, OH is attached with this carbon atom, so hydrogen will be removed from adjacent carbon. Similarly, second OH is present on this carbon and hydrogen will be removed from adjacent carbon. After removal of water, double bond will come between these 2 carbon atoms and these 2 carbon atoms, and this is the only product that is possible. The structure of product is like this. There are 7 carbon atoms and 10 hydrogen atoms in total. So only one product is formed. Option 2 is also correct. In third compound, OH is attached with this carbon atom and hydrogen will be removed from adjacent carbon. Similarly, OH is attached to this carbon and hydrogen will be removed from this carbon. So we can draw the product. Either double bond will come between these 2 carbon atoms and these 2 carbons, or double bond will come between these 2 carbon atoms and these 2 carbons. Now we can find the position of double bond in this structure. The double bond is between first and second and third and fourth carbon, while in this structure the double bond is between first and second carbon and fourth and fifth carbon. So both products are different. The molecular formula of both products is C7H10. Due to different structures formed, option 3 is incorrect. The answer is therefore B. Question 39. Hydrogen cyanide reacts with propanone in the presence of potassium cyanide. Which statements about this reaction are correct? Let's draw the mechanism for the reaction of ketone with hydrogen cyanide. The functional group present in ketone is C double bond O, where cyanide is going to attack on this partial positive carbon, and these electrons will move towards oxygen. The product form will be like this. Cn is attached with this carbon atom, while oxygen becomes negative. Now the lone pair present on this oxygen will attack hydrogen of HCN, and this bond is broken. So now the product formed is like this. We have carbon, OH group is formed, Cn is present, and Cn negative is formed. So we started with ketone and now we have hydroxynitrile compound. Option 1, the cyanide ion is a catalyst for this reaction. Now we can see that the cyanide ion has started this reaction and it is also present in the product. So therefore statement 1 is true. Option 2, this is an addition reaction. As we can see that HCN has been added into the product. So therefore this is true statement. Option 3, the intermediate behaves as a base. According to Lewis concept, electron pair donor is a base, so we can see that oxygen is donating its lone pair to hydrogen. So therefore option 3 is also correct. As all options are correct, the answer is therefore A. Question 40. Which compounds produce 3 different organic products when hydrolyzed? As we can see that the ester functional group is present in 1. It is also present in second compounds and also in third compound. So upon hydrolysis, ester will break down into carboxylic acid and alcohol functional group. The products will be like this. The carbonyl carbon portion forms carboxylic acid, while the other oxygen forms alcohol. Similarly, this carbonyl carbon will form carboxylic acid and this other oxygen will form alcohol. So 3 products are formed. First one is CH3, C double bond OOH. Second is CH2, CH2, C double bond OOH. And third is CH3OH. As all 3 products formed are different, so therefore option 1 is correct. Similarly, when compound 2 is hydrolyzed, the oxygen will form alcohol, while the carbonyl carbon will form carboxylic acid. This carbonyl carbon is also converted into carboxylic acid and this oxygen is converted into alcohol. The product formed a CH3OH. The third one is also CH3OH. As we can see that these 2 products are same, so only 2 products are formed. One is this one and one is this one. Therefore option 2 is incorrect. Moving towards option 3. Again we can see that carbonyl carbon will convert into carboxylic acid. and oxygen will convert it into alcohol. Similarly, this oxygen is converted into alcohol, and this carbonyl carbon is converted into carboxylic acid. The products formed are like this. As only two different products are formed, so therefore option 3 is also incorrect. The answer is therefore D. Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.